So here I will work through this matrix multiplication problem. The question is, we have two matrices, and the question is, what is A times B? So when we do matrix multiplication, we first need to be aware of what the dimensions of the matrices are. So A is a 2-row by 3-column vector, and B has 3 rows and 3 columns. So let me just transfer that these dimensions down here, and I recommend that you always do that. And in order for this calculation to work, for you to be able to make this matrix calculation, these inner two dimensions have to be the same. Okay, in this case they are both 2 by 3. So the result of this is going to be, we'll call that a matrix C. And what dimension will it have? Well, the dimension of the result will be a 2 by 3 matrix. So it will be these two outer dimensions which will determine what the dimension of the results is. So we already know we are expecting a 2 by 3 matrix. And actually, this is a great way to start. Draw a 2 by 3 matrix. So we know we need to end up with 6 values here. And now let me arrange the matrices A and B in a very particular way. I'll put A to the left of this. So here we have 0, 3, 1 and 0, 2, 1. And I'll put B, so this is matrix A, and I put matrix B on top of this box. So here we have 4, 6, 1, negative 1, negative 4, 2, and negative 3, 2, 3. And so this is B. And you can see here we have 2 rows meeting the 2 rows of our final result, and 3 columns meeting the 3 columns of our final result. And that isn't a surprise. This is by design. So the result here will be our matrix C. So now the question is, how do we calculate these 6 individual elements in C? So let's think of this first box. What this is going to be, that's going to be an inner product of this matrix times this matrix. And if we calculate, let me just get rid of these colors again. Okay, so if we want to calculate the inner product of this, we'll take 0 times 4, which is 0, plus 3 times 6, which is 18, plus, sorry, I realize I copied the wrong value here. So that should be a 2. Okay, but we didn't use the 2 yet, but I realized it now. So let's start again. The inner product of this matrix, of these two matrices, is 2 times 4, which is 8, plus 3 times 6. 3 times 6 is, of course, 18. So 18 plus 8 is 26, plus 1 times 1. So that is 27. So what about the next element, this element here? This is now going to be the inner product of this matrix times this matrix. Okay, let me take the colors away. Just a hindrance. So here we have So here we have 2 times negative 1, which is negative 2, plus 3 times negative 4. So 3 times negative 4 is negative 12, plus -2 is -14, and then 1 times 2 is 2. So we're ending up with -12. -14 plus 2 is -12. So and you can perhaps already see where the pattern lies. Now we're looking at this element. It doesn't matter in which order you calculate the elements. Now we're going to have this inner product of these two matrices. So 2 times -3 is -6 plus 3 times 2, which is 6. So -6 plus 6 is 0 times plus 1 times 3. Here we are left with a 3. So we're halfway through. Now we're calculating this value, which is now the inner product of this times this. 0 times 4 plus 2 times 6 is 12 plus 1 times 1. Here we end up with 13. Next one, we're almost done. Now we're calculating this value here, and that will be the inner vector product of these two vectors. So 0 times -1 is 0, 2 times -4 is -8, plus 1 times 2, which is 2, so -8 plus 2 is -6. -6. And finally, this last, the 2, 3 element, which is the product of these two vectors. 0 times -3 is 0, plus 2 times 2 is 4, plus 1 times 3, that is 7. So here is our result. This matrix is our result matrix C. So perhaps you can see that really matrix multiplication is nothing else but a combination of inner vector products. As long as you know that, and as long as you figure out what to multiply with what, you'll be all fine. It's all straightforward. And to make it easier, to this day, I arrange the matrices, if I have to calculate it by hand, in a way how I demonstrated it here.